Given two measurements of 12.45 centimeters plus or minus 0.05 centimeters and 25.70 centimeters plus or minus 0.05 centimeters, what is the product of these two measurements with uncertainty? Well, okay, product. Let me do the easy part first here. This example I think is maybe pushing the edge a little bit here with what we're doing, but I want to show you guys how something like this could work. And I think what I'd probably want to just start with is to say, well, the easy thing, like I said, is to take 12.45 multiplied by, is that clear enough? Multiply. Make sure you don't mix multiply and decimal, right? By 25.70. That's something I could just put in my calculator to get a result for, and I get, let's see, 319.965 for that. Now recognize, so that's implying that I got, since I'm multiplying these two measurements, these could be like a length and a width, right? And maybe I'm finding the area of whatever this is, the length and the width of. So in other words, units wise, the unit on this would be a unit of area, which would be a centimeter squared. So that's what I've got so far. But now I want it with uncertainty. Well, let me draw a little picture here somewhere. Maybe I can draw it over here. Let's say I have, like, I don't know, some kind of rectangle here that represents maybe the longer dimension of this rectangle could represent the 25.7. The shorter one would represent the 12.45 there. If we look at the effect on area, let's say that there was a slight error, right? So like, let's say here, this represents like a slight increased measurement, let's say, or whatever, slight difference in measurement for the 12.45. What's going to happen to the area is I'm going to add this sliver right here, which would really correspond, like if that little distance I added right there, which may be exaggerating the picture compared to something as tiny as 0.05, but let's say that represents an increase of the plus possibility, you could say, even though that's not really quite the correct way to interpret that, but it's one way of thinking about it. But it's a plus possibility, I'm going to say, of the 0.05 centimeters. Then I'm adding an area there, right? That would be an area of 0.05 centimeters. I'm going to keep the units here just to keep this all straight, multiplied by the other length, which was the longer 25.7 centimeters. So that's something I can put into my calculator. And my calculator says, pardon me, I made an extra mark there. It's one with a cross, I guess, but 1.2, it's crossed like a T, right? 1.285 centimeters. Actually, that should be centimeters squared, tracking the units. That's why I did that. I want to make sure, because these are all, this is like added area, right? In turn, like, what if some area got added to the longer end of this, right? So if that represents some added area there, that was like, maybe add the plus 0.05. Obviously, I didn't draw that at the same scale there, but whatever. Added to the 25.7, but that would then be an added area multiplied by this length here, which was the shorter 12.45. So in other words, I think what I'm describing there is an added area of up to 0.05 centimeters, because that's the error, multiplied by the other side's length, because that's kind of the impact that that error would have on the overall area of this rectangle here. So multiply by 12.45 centimeters, and then in my calculator, I'll try to mark it a little more legibly this time, but my calculator says for that 225 centimeters squared. So one simple thing to do is to maybe suggest that the error here, just take these two numbers and add them up, which, I mean, I put in all the digits my calculator had, but this is an error, so I should probably round off a little bit, and this is like 1.3 plus point, I think it's going to round off to about 1.9, so I'm seeing 1.9 centimeters squared, which is pretty close to 2 centimeters squared. So there's maybe a couple different options here. If I say it's 2 centimeters squared, I should probably round off my original area to 320, I think it would round off to. centimeters squared plus or minus 2 centimeters squared. So that's based on, again, on taking this option. But another option that would be perfectly legal, this is definitely, when it comes to errors, there's oftentimes, more than one option. There's some choices that are okay to make. In this case, I think if I kept the 1.9, if I decide to, because it starts with 1, sometimes it's okay to keep 2 sig figs when the leading digit is kind of small, because it kind of conveys more information to keep an additional digit there. Anyways, I'm going to get 320. I think in this case I'd want to, it looks like it would round off because that 965 rounded to 320.0 centimeters squared plus or minus the 1.9. So this is another option here. Another slightly more, maybe I'll say more better option, less biased, but it's less accruing of statistical error, kind of acknowledging the fact that these are plus and minuses. Instead of straight adding these two numbers, you could add them in quadrature like I did before, and it turns out if you do that, the number that you wind up getting for that would be just 1.4. So if you add these like they're sides of a right triangle. So I'm going to write that here as maybe a third option for the answer here is 320 centimeters squared plus or minus 1.4 centimeters squared. So again, that's sort of with quadrature, which I think takes into account the plus or minus a little bit better. We're going to learn more details of that later in this course, but I'm just kind of already showcasing it here. So that kind of covers all the possibilities that I could think of. The first two are kind of in our text. The last one, again, is using quadrature, that our text doesn't really do that, but that is considered a little bit better practice out there in the physics world, in the physics lab world. And I said on there, if this is confusing, and I also said should be for everyone, this is new stuff, keep coming to lab. In other words, keep doing lab assignments, because we're going to get more practice with this. Again, I'm just showing everybody some stuff, but you're going to get a broader base of knowledge regarding how to deal with error intervals, how to deal with them in calculations, and you'll understand. At some point, you'll look back at this and say, oh, I totally get that. It's trivial. At least I hope we all get there.